setting this up.
Good.
And okay, so you can see my screen.
Yeah, able to see.
Yeah,
Okay.
Go ahead.
All right, perfect. Okay, so good afternoon, everyone, and thank you for joining us today. And thank you, Murthy, for a nice introduction. I'm looking forward to present our talk with my colleague Sumit Daryani at the conference next week, and hoping to see many of you in person and meet with you and have a good conversation. So a little background about what we do at Capital One. We are working on operationalizing ML at Capital One for past few years. And we have built an ML platform entirely based on open source technologies. And that was like an evolutionary journey. We started off like everybody else and every other enterprise several years ago with commercial products, and quickly it became like a mesh of all different commercial products, because they are good at like few things but not good at everything that you want in an enterprise. So that has been our experience, and that led us to on our journey to create our own platform, which satisfies all of our requirements of today and for like considerable future. So hence we started our journey on this for past few years on operationalizing ML. However, in this particular talk, we are going to focus on the model serving aspect of the ML lifecycle. Okay, so what are we going to expect from this session? So this is like basically an overview of model provisioning and servicing. And as I mentioned, in this talk, we will focus not on like training aspects or retraining, refit aspects. We can certainly cover that in the Q&A after the session, but primarily really focusing on like how do you do this provisioning and servicing model and at a scale, and with all the software engineering DevOps best practices that you have evolved over the years in your enterprise. Then some of the architectural choices to make and consider to sustain the growth that you anticipated your enterprise. And lastly, like how to achieve operational excellence with doing all these while serving like the model for your own business, solving business problems. Okay, so this is like a very well-known picture that I'm assuming everybody has seen. Like it's I see that in every almost like every other presentation on ML.
Yeah.
So that is like the reason to highlight that, but we can't get enough of this, right? Because depending on where you are in your journey, where you are in your organization, or where you are in the pipeline, you will fall under these various boxes, and these boxes are more or less like sort of boundaries of these kind of functions that each one would require to complete in order to have the complete life cycle of the pipeline. So as you can see from this, like model building takes up like the majority of the whole cycle, and then model serving takes the other half. But then even in the model serving, if you see the ML code right at the center of this is like very small portion, or the percentage wise when you compare to the rest of the things, right? Because it's like you need to figure out like how do you validate your model once it goes to production? How do you like manage your resources to scale to take the into account your business growth? What kind of tools you would be using to do the analysis, the testing of your model? What kind of process management tools you would leverage to do achieve your operational excellence? And then like the last but not least, the monitoring aspect of it, not just for your model, because data scientists have probably created their own various solutions to do the model performance monitoring, but you have to manage your infrastructure as well, right? The model serving infrastructure, you need to monitor that and make sure that you are able to meet the demands of your applications or the business solutions that you have put in place. So the majority of the time is being spent not in the model development, but after you develop the model, then putting that to production. And then once you put that to production, how to monitor, how to refit that, how to keep on enhancing and learning from it. That's where the majority of the time is being spent. And that whole timeline goes from few months to several months, depending on the maturity of the various organization and the solution also that you have architected, right? So our intent is to crush those timelines and bring it down from months to weeks. And that is what we intended to do here with our offering as model as a service. So the goal is to have empower data scientists and to do help them do what they do the best, which is development of the model, and be able to deploy that quickly without the help of relying on engineering teams, for example, or relying on a bunch of other individuals, right, to take their model to production. They should be able to do that on their own, and the more you help them do that, the more better model they can develop. Because many of the times in large enterprises, the model development is no different than the software development, right? It is a lot of trial and error. In case of software development, we do trial and error by running various scenarios. In case of model, the trial and error depends on what kind of feature engineering you do, what kind of feature you're going to feed in, and then changing and tuning one thing at a time to get to the optimal model, which is going to be compliant with your governing bodies at your enterprise, right? Because when we are talking about these enterprises who are using and leveraging machine learning based model, which affects their customer life, then obviously there are governing bodies involved, which wants to make sure that we are doing things right, legally, ethically, and not letting the bias seep in. So that's why it is very important to have them, give them an ability to be able to deploy their models as quickly as they can, and then generate this analytical data set. So that can be fed into this, and that's what they can do afterwards. So that is what what we're gonna cover. So I'm not gonna give up too much of information from our talk, but I think there are some of the key things, right? So what are you going to learn out of this if you come to our talk? So at a very high level, how to host models and productionize them efficiently, how to automate this, what kind of architecture supports this, and how we are leveraging the open source technologies to, because when we hear open source technologies, typical reaction from many folks at the enterprise would be that, yes, it is good for POCs, you can do prototyping, but then you cannot take it to the enterprise level and scale it to support our production requirements. For that, we need to either have a vendor who does provide services on top of open source software, or we need to go with the commercial. So you're going to get some of the tips and based on the architecture that we selected, right? And then how to deliver well-managed ML pipelines. And I say well-managed because that is the mantra for many of the enterprises, because the last thing we want is to get on call every night to go and debug and or support the deployment that it went wrong. So that's why having that well-managed aspects and considering different kind of gates in your automation is what we can show and share from our experience. The next thing is who is this presentation for, right? So who is our target audience? So I would say our target audience is a mix of everything, technologists, ML engineers, architects, and the leads of various organizations who are interested in building something for their own enterprise to this scale and this kind of sophistication. And somebody who is having doubts as an architect or as an ML engineer that why I want to leverage like open source technologies and why I want to give up my commercial product in favor of this. So you will definitely get something out of this, and during the presentation and after the presentation by chatting with us offline during the networking events. Data scientists and data engineers, because those are our primary target. Data scientists, the primary target for this kind of architecture and solution we have put in place. Data engineers, of course, because they manage the pipelines right now, so they need to be like able to like see the value in this. And then, of course, lastly, the product managers, because if you cannot sell the product to the business, you will not get the right kind of resources to put in place in order to deliver your value. So, and then the next thing is like, so what are the benefits to the ecosystem and takeaways from our presentation, right? So one thing we have seen like, in the past, after giving the presentation and talking to people, is that many people are facing the similar kind of challenges in their enterprise. And then when they see and hear about how we have done this on open source technologies and how it is helping us and where we are in the journey, they gain confidence in like trying out something on their own with similar approaches. Identify techniques and employ them to build their solutions, and what are some of the pitfalls to avoid, which you are definitely either experiencing or will experience as you move along. And also like acknowledge and recognize open source technologies that are available to all of us right now. And we are a big proponent of that at Capital One for open source technologies. We contribute back to the communities with various opening up various products and like contributing to the existing products. And then lastly, we're also going to talk about like how this particular approach has helped our organization at large and what kind of impact.
So what I'm doing is just like Niraj did, I'm going to give you a little teaser on what my main presentation will be. So it's only about 5 slides, I think, not a whole lot. And the topic is toolkits and SDKs for AI, ML, and big data development and training, also for deployment.
Yeah.
So first of all, AI and big data will touch pretty much every industry one can think of. Some may be earlier than others, but eventually it will touch all of them. And common ones that we all know of are manufacturing, automotive, healthcare, retail, banking. Or you could add to that, financial services. You could add to that oil and gas. You can add to that supply chain management, and so on and so forth. But it touches pretty much every industry. And basically, what is going to happen is that the same AI, ML, and big data technologies will basically need to be used across them. There are only a certain number of such technologies, and they apply pretty much across industries. And just to name a few, there are neural networks. Again, neural networks are different types. There is natural language processing, natural language understanding. Then predictive analytics is becoming a big area right now, because many companies are getting into predictive maintenance, into forecasting, and things like that. Reinforcement learning is a new area of AI that is becoming very popular, and not just popular, it's a very powerful area of AI that's emerging. And then finally, one of the newest things that's emerging is causal discovery, which is understanding the reasons behind certain trends occurring in various industries. All of these technologies basically can, although they are all AI, ML, and big data, they apply across industries, and as a result, there needs to be some structure to how they are implemented and deployed. And on that note, the need for structure and reusability is immense. And I've broken this up into basically 3 categories. The first is development. The second is reusability of the use cases, because many of them will map across industries. And a third is the availability of data and algorithms, which is not to be underestimated. You very often find that there are certain industries which are maybe leading. Whatever they do, if other industries have access to those technologies, it'll just speed up the development in those industries too. So as far as structured development goes, the idea here is essentially to have consistent, ready-to-use tools and fast, iteratable prototyping, meaning one will try something and then get some results and then be able to try different variants of it. When we talk about use cases, in many scenarios, what happens is that the use cases are they need to be constructed from scratch. And if there are existing use cases that are available, maybe in a different industry or maybe even in the same industry for a different application, to be able to leverage them is incredibly helpful. And the third is the availability of data and algorithms. I think almost all of you must have heard that in AI and ML, certainly in big data, data is king. You need data for pretty much everything. Some of this data is can be generated ahead of whatever algorithms are being implemented. Some data has to be generated along with the use case proceeding. But in any case, this data, if it can be made available to people, and also the accompanying algorithms, if they can be made available to the development community, it just speeds up not just the development, but also the adoption of these industries. So there are a number of frameworks in AI, ML, and big data. I'll touch upon a few of them. And the framework themselves, again, some of these names I'm sure are very familiar to you. TensorFlow is one. I'm sure you must have heard of TensorFlow. Then PyTorch is another popular framework for AI development. There's OpenAI, there's Unity. H2O.ai is a popular framework. Again, these are just the 5 of many, many more, but these are the more popular ones. What they're used for is largely for development of the applications, and they contain APIs for AI and ML development. They support a fairly large number. In fact, in my opinion, they support pretty much all the well-known AI ML algorithms that are required for pretty much for any industry or for any application. They have a wide range of available libraries which can be used with many different languages such as Python, C++, JavaScript, and such. And in terms of the actual technologies themselves, they support convolutional neural networks, they support reinforcement learning, they support recurrent neural networks, natural language understanding, clustering, and much more. And these tools and frameworks are basically the pillars of development of applications. Without these frameworks, it becomes much more difficult to develop applications from scratch. So these tools and frameworks really are all important in building applications quickly and efficiently. One area that is not discussed a whole lot, but I think is supremely important, is simulators. And they serve a very, very important role in the industry. First of all, they let you simulate real-world conditions safely. That cannot be overstated. There are certain industries where you simply cannot go to the real world for everything that you need to test. For example, in autonomous driving, one of the things is you need to be able to learn from good outcomes plus bad outcomes, and bad outcomes are crashes or accidents. Obviously, you cannot go and crash a million vehicles. That simply will not fly. And simulators are a very good way to let such testing be done in the safety of a computer and a screen before taking the product out into the real world. You can implement adverse scenarios, as I mentioned. You can generate very large labeled data sets, which are required in many AI and ML applications. Very often in the industry, the typical mode is to take a camera or to take some other sensing devices and go to the real world and capture all the data you can. The problem is that tends to be very labor intensive, tends to be incredibly time consuming. And moreover, what you end up with is sparse data of which there are not enough data types. and simulators let you get such data in large volumes. And finally, the simulators let you experiment with numerous variations very readily. So simulators are an incredibly important part of essentially generating AI and ML and big data applications. And finally, in big data, obviously this is again the counterpart to AI ML. And again, I think many of you must have heard of these frameworks. Hadoop is of course known universally. MapReduce is probably a little less well known, but nonetheless equally important. And Apache Spark is Apache Spark, Hive, and Kafka are again three other big data frameworks. But what these frameworks let you do is they let you store and organize very, very large data sets. They let you perform statistical and AI analytics on these data sets. Again, much of it is, often this is in conjunction with the AI algorithms or AI frameworks too. You'll very often find Hadoop as well as, say, TensorFlow going together. You can combine them with AI algorithms in that context. And the final thing is that it lets you perform both post-processed as well as real-time analytics of variations in data. So this is just a teaser for right now. I wasn't planning on going through all of it, but for my main presentation, I'll have some more detail on each of these, including some fairly interesting use cases that I'll talk through. So I'm looking forward to the actual session coming up on the 23rd and 24th, and hope.
All right, thank you very much for the introduction. First of all, I really appreciate the opportunity to share a little bit of my work, the work on my team here that we are doing inside HP. Like the previous presenters, I have put together a couple of slides, 3 to 5 slides, and this is just to give you an overview of what you can expect on my talk. So the talk is scheduled for August 22nd from 1:50 to 2:30 p.m. And during this time, I'll be talking about, actually I'll be sharing our journey to create this serverless approach that is able to pull data and deliver insights and recommendations using IoT. I'll get into the details of what that means on this overview. But before starting, I would like to take the opportunity to share from this moment on. If you have any questions or need any details about the presentation, feel free to reach me out. The website has all the contact information. You can add me on LinkedIn, and we can start to exchange information from there. So I will skip this slide. This is the introduction. I work, like was said, I worked for HP for the past 12 years. And one thing that I had the opportunity to be a speaker on other conferences. Every time that I mention that I work for personal system software, some faces are surprised because when we think about HP, we usually think about hardware, right? If you say the name HP, you think about printers, you think about PCs, workstations, laptops. But sometimes we forget that underneath those boxes, there are lots of software. And inside the business unit that I work, specifically the personal system software, we have built softwares that are installed on multiple devices. And here I'm taking just the personal systems as an example. So think about laptops and PCs, right? We are collecting data from more than 30 million devices. And this data we receive in our backend, and we extract that information at least once in a day. When we collect data that is related to all sort of hardware information, like the disk telemetry, thermal telemetry, memory telemetry, everything that you can imagine. We are observing in order to create and to learn from the experiences, right? And the biggest part of my job nowadays is to create solutions that can help the users, and while doing that, we can still amaze them. Like, we are used to take our phones and to get extreme experiences. Like, when using iPhones on Android devices. It's like Apple and Google, they know us, right? Because they learn from the usage that we do, and they can deliver personalized experiences. So based on this scenario of where we are collecting data from multiple devices, and we are putting those information throughout our pipeline, our machine learning pipeline, we do some cleaning on that information. We apply multiple and different machine learning techniques and algorithms, and we can create what we call the gold information, which is basically a collection of insights and recommendations, right? And the first problem that we had was that, well, we have lots of information, we have lots of insights, but how we are actually using those insights. We can, produce reports with that information that will basically sit on the desk. If nobody does anything with it, the problem will still persist, right? So the talk that I'll be sharing with you is basically divided into two phases. The first phase was how we address this problem of democratizing the access to the information, and the second phase is more like what we can do with that information. So for the first part, we started to create or to think ways to create a solution that was always accessible, meaning if the user is sitting in front of the computer, he can get access to the information. If the user is away from his desk, for example, and needs to get some data from the computer, he can get it through the mobile application. So during this first part, I will tell you how we create this solution and what we did to, create a better user experience. And to give you a teaser of what that means, it is all about natural language. So we started to think as humans, how we get information that we want. And one of the answers is we ask questions and we get responses. And if the responses that we are retrieving are not exactly what we need, we usually ask for follow-ups, right? So we put together a solution that was able to do right exactly what I mentioned. So we can ask questions and we can get the responses. And then we started to think, hey, since we have access to the devices, because we are getting telemetry from them, and we have the insights, we have the recommendations, meaning we know what we can do to help the user, why not deliver that insight, right? So this is what I mean by delivering the insights and recommendations using IoT. So the second half of my talk will be to describing in details how we put together this proof of concept that connected multiple devices using IoT to deliver those insights. And one example of that is, let's say that based on the telemetry data, I understand that your disk has some issues and will be, failing soon. Before that failure point, I can get in touch with the user and let him know that, hey, I identified a problem, but don't worry, I'm going to help you fixing this, or at least I'm going to help you to create your backup, to put this in a safer place. I would also recommend a place that you can, ask for the replacement and all those sort of things. But at the same time, we realize that we can identify a potential problem, but we might need some additional information. And to address that, we are not only delivering the recommendation or the insight, but also using that platform to collect specific telemetry data. So we can intensify the telemetry to, drill down on the problem and make the right decision about the problem. With that, I want to wrap up and say, again, thank you for the opportunity. I'm looking forward to meet you all there at the conference. And again, I think this is a very exciting area. I just give you an overview of what you might expect from the talk. But during the talk, we we can go deep into the details, and we can address all the questions that you might have, and we can exchange experience and the learnings specifically that our team here had in order to solve this particular problem.